One person, by the way, we're recording now, there was one person who filled out the ed puzzle. So Elizabeth, if you end up seeing this, that's why your ed puzzle's gone. I deleted it. For the rest of you, if you saw an ed puzzle post, it has been removed. So don't stress the new ed puzzle. In fact, really what I want us to focus on now as we get down to this last month of school is finishing on a strong note and getting any and all missing assignments or ed puzzles in, really focusing on that moving forward. Assignments are looking good. We have the textbook assignments. That's where you hear on number 3, it says assignments text. So those are our textbook assignments. We will be doing some of lesson 6 today, hopefully finishing that. And then we have some quizzes. Period 2, you're crushing it. I think 24 of you have already turned it in. Period 1, I think like 17 or 18 of you have done it. So both classes doing a really good job on the quizzes completion. If you're listening to this and you haven't completed it, no stress. We've got plenty of time, 4 weeks left. Effectively, what I want to say before I go into the last thing here is, I know you might see deadlines on the due dates, on the assignment due dates. That's not where my focus is at right now. My focus is on getting y'all through this finish line and assisting you in every way possible. So if you need to take more time to get those assignments in, I don't care, quite honestly. Okay, I've kind of been postponing telling y'all this, just so that way you didn't really feel like you didn't want to do the work and you'd push it off and procrastinate till the end. But that's kind of where my head's at. If you get the work into me before the final grade is due, I will get it in the grade book. Okay, so that's really where my mentality is at right now, focused on doing it rather than doing it before a deadline. Cool. Extra Zoom session, office hours, 11 a.m. on Friday. Hopefully I'll see you there. Right on. Okay, so real quick, actually, before we jump into lesson 6 today, let me jump out to that remote learning agenda thing that we look at basically at this part of class every single day. Notice I have checked off here on the left side everything that we've done, little checks, and everything that we haven't done, I haven't put in a check next to. But you can see here today's Cinco de Mayo, May 5th, 5/5. We're going to finish up lesson 6 today, and there is a quizzes that's extra credit if you get over 75% attached for it. As we cruise on down, I think this might be where a majority of us are kind of focused in the concept of finishing this class, and that's the final. We obviously know, or if you don't know, there's not going to be a standard-based final. And what I mean by that is the typical final that you've taken in previous math classes and that you took in my class first semester. Instead, what we're going to do is I'm going to assign a log project, and we'll talk more about that when the time comes, a little bit closer, like the middle of this month, probably around this 5/19 or 5/21 time. But the log project will be pretty straightforward. It'll be asking you to make decisions based off our knowledge of logarithms, and that's effectively going to serve as our final for this year, okay? So pretty low stakes in that sense, no stress over it. If you have any questions between now and my formal discussion of it, never hesitate to reach out and ask, okay? So that's why I wanted to go back to the RLA here. All right, so lesson 6, we started it last Thursday. It's basically the culmination of all of our knowledge of the unit circle as it relates to angles, radians, and now our coordinates on the unit circle, because keep in mind this is all on the coordinate plane with the center of our circle being at the origin. It's effectively our culminating lesson on all of that, where we start to really see how sine and cosine relate to movement around a circle. That's what we're going to do today. So without any further ado, I'm going to turn it to page 76 and 77. We'll do a few of those problems, and then we'll get some of the homework, as much of the homework as we can done, okay? But before I start with number 6, I'm gonna take a quick drink of water first. All right, cool. I'm ready now. All right, page 76, number 6, piggybacking off what we've talked about basically for the last 2 weeks, specifically last Thursday, we now see unit circle can be described in terms of angles. We called that theta. In terms of a radian measurement, which is the purple distance around the circle. And now in terms of location awareness, like north, south, east, west, kind of we use that as humans on a non-typical coordinate plane situation. Long story short, we can also describe it as a coordinate XY. And on Friday, we basically summarized the following, that the sine of anything on the unit circle always relates to the y value, and the cosine of anything theta being our theta, that little 0 with a dash through it, being our variable for an angle, is always the x value. Sine y, cosine x, cheesy way to remember it, but I always kind of think about a y having the ability to be like an I sound, like in the word my or fly. Obviously, a y can have a hard I. Thus, I kind of think about sine having the I sound and the y being associated with it. Just kind of a memorization tool that I've used. Now, basically what we're going to do as we wrap up this lesson is use that knowledge that sine is the height, sine, and cosine is the horizontal, the side-to-side movement, to our advantage. All right, so on page 76, 6a, in the diagram above, what is the sine of theta? Well, the sine of theta is just the height, which all that we know about the height in this case is the y, and the cosine of theta is the horizontal movement. And again, all that we know about this point right here is that it's some x and some y, no actual defined variable values. So how else can we name the coordinates? And this is kind of just a reiteration of the same material, but the coordinate xy in trig speak could be called, x is cosine, and y is sine. So you could call any coordinate plane or any coordinate on the coordinate plane basically a combination of sine and cosine there. And the final thing that we're going to do is we're going to move on down to the next page. Then it's homework time, hopefully getting this done for y'all. Is as I move on down, we're going to try numbers 10 and 17, and this is on page 77. So if you're looking at the PDFs that I uploaded for y'all in the Google Classroom, they did not include this, the unit circle. But also keep in mind that most of the unit circles are available via online. Quick Google search, all you got to start typing in is unit C, it'll pop up. Or on lesson 5 in the summary, there's a unit circle there for us as well. So here on page 77, I've copied and pasted a unit circle in here just for the sake of getting through this problem relatively easily and quickly. And we want to find the sine and cosine, specifically on number 10, when theta, or our angle displacement, is 60. So I'm going to highlight 60 here. I'm going to cruise on over to my unit circle, and I'm going to look for where we have an angle of 60 degrees, which is right there. So really what that means is that this angle there, that theta, is 60 degrees, a movement of 60 degrees. And it's now asking me at this angle of 60 degrees, where our radian, by the way, is pi over 3, it was asking me what's the sine and the cosine. So remember, sine is always the y value, and cosine is always the x value. So all I'm going to do now is look over at that x and y value at 60 degrees and then write it down. So I see over here, and I'll highlight it in a different color, that my x value is 1/2. So therefore the cosine of a 60-degree angle, the x of a 60-degree angle, has a horizontal displacement of 1/2. And yes, my y, my sine, is √3/2. It's kind of at this point with the unit circle, it's basically like a matching game, or kind of a Where's Waldo, so to speak, where we have to understand what we're looking for. But once we understand what we're looking for, it's basically a process of copy and paste, so to speak. At least at this point, with where we're at in remote learning. Okay, last thing I want to do is now figure out, let me highlight in a different color, number 17. I picked one that was an angle, number 10, and one that was a radian, number 17, so we could get a little practice with both. And I want to figure out when your theta, your angle of movement, is 2 pi over 3. So I'm going to kind of zoom out a little bit here, keeping in mind that we always start in the center. My initial, or my starting side, is trending out towards the 0-degree angle. And I want to figure out where 2 pi over 3 is as a radian. Boom. So what that radian 2 pi over 3 basically means is this. I went 2 pi over 3 units around that circle to get to this spot here. So again, sine says, okay, tell me the y value. Cosine says, tell me the x value. So now all I got to do is go to that spot and write the y value, √3/2, and the x value, -1/2, and voila. And basically, another kind of double down why I chose specifically 10 and 17 is so that way we could see the relationship between 120 and 60. Not only are they 60-degree increments, but you can see here that the y values are identical And the reason for that is because they're at the same height. They're just horizontally across from one another. And then we get out all the extra coloring here. These two y values, there and there, are same height up. They're just on opposite ends of the y-axis, which is why you can check out here our x values are both 1/2. One is just negative, while the other is positive 1/2, because again, they're the same distance away from the center, just one is on the left side as opposed to the right side. And we'll see that consistency in every single ordered pair on this unit circle. What I mean by that is effectively every single thing on this unit circle, every single ordered pair is legitimately the same combination of numbers, just with pluses or minuses. Every single one are the same values because we're using our same major reference angles, 30, 45, and 60-degree angles. They're just depending on where they are on the coordinate plane, left or right of the origin, up or down below the origin. We have the positive or negative x and y values associated therewith. And that completes Unit 13. All right. It's kind of felt like a long time that we've been on that. I really wanted to not necessarily focus on the memorization of this behemoth unit circle. Tackling that, even when we see each other on a daily basis, is very difficult, but doing so on a 19 participant remote learning session, even harder. Okay, so that is kind of where we're trying to trend towards our understanding of trig at this point. Now, let's do the homework, because I'm sure that's probably where our mentality is at right now, and I don't blame you. All right, okay, homework problem set. We cruise on down. Sorry, this is on page S80, so we're on page 80 now. This is in lesson 6, in case we kind of missed that earlier, and we're doing problems 1, 3, and 5. We'll try to move through this relatively quickly. What I'm going to do is, for the sake of this problem, I'm actually just going to literally steal this unit circle up here. I'm going to paste it down right next to us, just again to make the process of this a wee bit easier. Okay, here we go. There's our unit circle right up there for us, and I'll kind of try to zoom in and out on it without giving you a headache as best as I can. So first thing I want to do is I want to figure out all this information about a 120-degree angle. I want to figure out the measure of the reference angle in degrees, and then the cosine and sine of that. The first part I think is the hardest one. The second one is just, hey, cosine is x, sine is y. So I'm going to find a 120-degree angle up here. Boom. Okay. And then second part was, hey, what's the reference angle of this? The reference angle are the big three, 30, 45, and 60. And all of those 30, 45, and 60 are always in reference or being used in relation to the x-axis. So the reference angle of a 120-degree angle would basically be this missing piece right here. How far away are you from that x-axis that's closest to it? And the answer to that is, well, if this is a 180-degree angle and that's a 120-degree angle, well, then we have to be 60 degrees away from the closest x-axis. So our reference angle for 120 is basically 60 degrees, which is why you notice when we look at a 60-degree angle here, boom, our coordinates are the same, just positive and negative. So now we can really quickly and easily move past that and say, all right, reference angle of 60, same 60-degree angle coordinates, cosine is x at a 120-degree angle, because keep in mind that's still what we're looking for. The x value at 120 is negative 1/2, and the y value at 120 is positive √3/2. All right, before I move forward, does anyone have any questions on how I solve number 1, both as to probably the hardest thing, how I determined the reference angle, and then thus how I figured out the sine and the cosine of that? If you do, either unmute yourself and let me know, or type it in the old chat box there, and I'd be happy to answer it. If not, we're going to cruise into number 3 in about 7 seconds. Internal countdown going on in my head. All right, off we go. Number 3, again, if you have any questions, even if you pass that 7-second mark, type it in, let me know, I'll answer them. Okay, 150 degrees. Same game, different problem. Let's do it. So I'm going to change my color up here, change my color scheme, make it a 150-degree angle. Boom, there it is. First question was, what's my reference angle? Well, it is only 30 degrees from the closest x-axis, the flat line of 180. So my reference angle for 150 is 30. Cool. What is the x value here? Negative root 3 over 2. X is always cosine, so cosine is negative root 3 over 2. And sine is positive 1/2, the y value. Right there. All right. Based on the fact that we had no questions on number 1, and we just saw a repetition of the same logic on number 3, let's just finish off strong and do an orange, number 5. Now on number 5, we want to find a 225-degree angle. So here we go. Let me draw it in. We figure out starting at 0, initial side, it trends all the way around to 225, which means, boom, there's our 225-degree angle right there. First question is, what is my reference angle? Well, from this point right here, what's the closest x-axis? Right there. How far am I away from it? Well, 225 is where I'm at. That x-axis is 180, so therefore I have to be 45 degrees away from it. Okay, maybe we're seeing consistency that our reference angles, and by the way, I purposely chose one of each, 60, 30, and 45, but our reference angles are always just the big three that we learned in geometry, 30, 60, 90 triangles, 45, 45, 90 triangles. Now just thrown into circumference convo when we talk about radians. Cool, let's make quick work of this. Cosine and sine are the same here because notice this ordered pair has the same x and y value, and that is negative root 2 over 2, the x, and sine is the y, which at the 225-degree angle is still negative root 2 over 2. First 3 problems of the lesson 6 assignment done. Right on. Cool. Find the exact value of each trigonometric function. Sweet, guess what? We actually legitimately just did number 8 in number 5, because on this one it says, hey, find the sine of 225 or find the y value at a 225-degree angle. Let me write that little at sign a little bit better. Boom. Hey, we just did that. Cool. There's the y value. Negative root 2 over 2. Thanks, number 5. And also number 10, sweet, we just did that in number 3. We said on number 3, find the x and the y value at a 150-degree angle. Well, we actually just did that. We are asking for the cosine, aka the x value at 150. So what was the x value at 150? Negative root 3 over 2. It's like reading a map. Once you know how to do it, it's just about finding it with the eyes. Okay, I'm going to pause here for a quick moment of relaxation and or catching up, letting y'all do numbers 1, 3, 5, 8, and 10 if you are participating in taking this down, which I would recommend because we're trying to get this done for you here, free up some of your time to do maybe some other things. All right, cool. Moving on. If you need help, if you need me to go back, holler at me. But we are now on number 16, finding the exact value of cosine of a radian. That's all right. We may not have done the radians in the last example. That doesn't mean we can't do it. So let me just copy and paste this unit circle there again. Now let's figure out where 5 pi over 3 is. By the way, here's how I'm going to zoom in on it real quick. I know 5 over 3, the improper fraction, is bigger than 1, aka 1 2/3, which means I'm already going to be more than 1 pi away. So I know it's got to be somewhere in this area. And sure enough, well, looky here. 5 pi over 3, boom, right there. So 5 pi over 3 is equivalent to 300, and what we're asking to do when we say, hey, find me the exact value of cosine at 5 pi over 3 is say, tell me the x value at 5 pi over 3 or 300 degrees. And sure enough, the x value is 1/2. All right, let's see what else we have to do. Sweet, we only have 2 problems left, 25 and 29. We'll get those done here. And then we'll call it a day. So cruising on down, skipping this page, going on down to page 83, looking at problem 25. I'm going to copy and paste this unit circle one last time. And on this unit circle, it says, okay, between the intervals 0 and 2 pi, which is a fancy way of saying around the whole circle. From 0 all the way around the circumference to 2 pi, aka within the unit circle, where do we have a cosine or an x value that's root 3 over 2? Well, right off the bat, I'm going to narrow my focus. Since I know my x value is positive, it has to be on this side of the pi. Has to be, because x's are only positive on the right side of things. Therefore, somewhere within that shaded blue region or on that right side of the circle is only where the x values are positive. And sure enough, hey, look at that. Positive root 3 over 2, positive root 3 over 2. Where do those exist? I'm going to use my angles, and that's at degrees of 30 degrees and 330 degrees. And last but not least, number 29. Let's use, which color do I never use? Oh, let's go gold. A little school pride. Again, on the interval from 0 to 2 pi, which is just really a fancy way of saying making your full way around the circle. No double ups. Whereas do we have a cosine of 0? Well, cosine of 0 means when you have an x value of 0. Where's the only way that you can have an x value of 0? Back in Algebra 1 and in this class, technically, we don't spend as much time in it, but we call those y-intercepts, or it hits the y-axis, which are at the quadrantal angles of 90 degrees and 270 degrees. Boom. Boom. And that, everyone, wraps up our entire lesson, our entire unit on unit circles. It's been a journey. It's been fun. It's been long, but it is now done. So on that note, we're going to call it a few minutes early today. If you have any questions, please stick around, and I would be happy to answer them. If not, I do, as always, appreciate you so much for being here. Hit me up with questions via email or the RLQ, and I'll see you on Thursday, okay? Bye, y'all.
Thank you.
You're welcome. Have a great rest of your day and a fantastic Wednesday.
Thank you.
You're welcome. Take it easy.